Alright, in this video we're going to talk about Unit 1, Objective 2, sketching the graph of a derivative. So, a couple things we need to know before we can sketch the graph of a derivative is what a derivative actually is. So, the derivative of a function is itself a separate function that represents the slope or the rate of change of the original function. So we're going to be defining this whole new function that's basically just going to take the slope of our original function and turn that into y values of our current function. So derivatives are going to be useful because they're going to tell us how a function is changing at any instant or any given time, not just over an interval like the average rate of change. So the average rate of change we saw told us how we change over a certain time interval from A to B. A derivative is going to tell us how we're changing at a certain instant, at any given time, instead of just over two different points. There's going to be a bunch of different notations for the derivative that you need to know. The two most common are if you start with f of x, the derivative of f of x is going to look like this right here. And we read that as f prime of x. It's going to work the same as if we start with y, we're going to end up with y prime. We could also, if we start with y, we might end up with dy over dx. So that's going to be, d is for delta. So it's going to be the change in y. So that's also where this delta y over delta x comes from, the change in y over the change in x, right? Because this is just the slope of the function. We could also end up saying d dx of f of x. So we would read this as the derivative of f of x with respect to x. That's what that dx in the bottom stands for. So again, the derivative is just going to tell us the slope of a function. And it itself is going to be a function. So let's talk about how we're going to end up graphing a derivative. When we're asked to graph a derivative, there's four things that we're going to need to do. First is we're going to need to find when the slope is 0. And that's the slope of the original graph. So find when the slope of original is 0. Sorry about that, is 0. And we want to plot those points. After that, we want to find the intervals with a positive slope. So find the intervals of positive slope. And when we go to graph, these are going to be above the y-axis. Right, so a positive slope is going to turn into positive y values, so those are going to be above the y-axis. Step 3, we want to do the same thing, but with negative slope. And that's going to be below the y-axis when we go to graph. And then finally, we want to go ahead and sketch our graph. Now, we're not going to be able to necessarily get the exact graph of the derivative. These are always going to be sketches. So we want to start by finding when the slope of our original is 0, plot those points, find the intervals of a positive slope, those are going to be above our y-axis, find the intervals of negative slope, those are going to be below the y-axis, and then we're going to want to sketch. Now the reason we want to do this is because the derivative is going to be useful later, telling us when things are increasing, decreasing, finding maximums and minimums, all kinds of different things. And we're going to need to know about how the derivative works if we're going to figure these things out. So let's jump in and look at an example of what we're actually supposed to be doing here. So in this example, I've given you the graph of f of x over here. And we are supposed to graph f prime of x. So if we go through the steps that we just outlined, we want to find everywhere where f of x has a slope of 0. So we have positive slopes over here, negative slopes over here. So if I went from a positive slope to a negative slope, right around here, we have a slope of 0. So if we drop down, that's a little bit past 1. So over here we're going to go a little bit past 1, and we're just going to put a little dot. So remember, the y values on our derivative are going to be the same numbers as our slopes over here. So if our slope was 0, our y value's got to be 0 over here. So then we look at, again, we have negative slopes, we have positive slopes. So our slope right here is 0. If we're going to change from a negative to a positive, so that's a little bit before 3. So a little bit before 3, we're going to put another y-intercept. Right? Slope of 0 turns into a y value of 0 over here. And then what we want to look for is intervals of increasing versus decreasing. So if we look, everything from the beginning of what we're given all the way up to that first 0 slope that we have is a positive slope. So that means everything from the beginning to here is going to be above the y-axis. And then if we look, everything from the second one all the way to the end also had a positive slope. So everything from here to the end is going to have a positive slope. So we're going to go ahead and graph our positive slopes. So remember, we can have on our graph a negative slope. We just want to make sure that our y values are positive. So remember, the slope here becomes the y value here. So the slope was positive, so the y values are positive. And if you think about it, the slope's pretty steep, and then it gets more or less and less steep, gets closer and closer to 0, which means our y values need to get closer and closer to 0. Then if we look in between the two places where we had 0 slope, so from here to here, we have a negative slope, which means over here in between the two of those, we want to have y values less than 0. So you can see that this kind of looks like a parabola. Now again, it's going to be a sketch. I don't know how far down this should go. I don't know how steep these sides should be. But this is going to be the general sketch of what this derivative should look like. So there's one more example that we're going to look at. And it's actually going the other way. So in this example, we're given the graph of the derivative, and we're asked to graph the actual function. So we actually have to think backward a little bit here. If we look here, everything from negative infinity up until 1, the y value of my derivative is negative 1. So that means the slope on my original function is going to be negative 1 until I get to 1. Then if we look from then, our slope jumps up to about 1.5, right? So then the slope turns into about 1.5. And that change happens at the x value of 1. All right, so that change jumps right here at 1. So we know at 1, I have to change from a slope of negative 1 to a slope of 1.5. Now again, we don't know what the actual y value is. We just know that our derivative has to change. So again, we're just making a sketch, right? Sketch the function. So I'm just going to put our dot right there. If we had a slope of negative 1, our graph would look something like that. A slope of 1/2 or 1.5, so we're going to go up 1.5 and go over 1. So it kind of looks like we'd have an absolute value, except this side's a little bit more steep. So the big thing to take away from this is the derivative tells us the slope of the original function. So in this case, that's where the negative 1 and the 1.5 came from. On the last one, we would work backwards. So we'll call it quits on that video, and we'll see you in the next one.